if dielectric constant is there, then this is your final formula, epsilon naught A divided by D minus T plus T by K. This is when your dielectric slab is partially filling it. And if instead of the dielectric slab, you have a conductor partially filling it, then the formula is epsilon naught A by D minus T. Then we had also discussed potential energy, capacitance, the energy stored in a capacitor. So in whichever form you prefer it, you can write it in that form only. Q square by 2C half CV square or QV by 2, any of these formula. If you are given charge and capacitance, then use the first one. If you are given capacitance and volume, capacitance and potential, use the second one. If you know the charge and potential, use the third one. And we had discussed a formula, then we had seen the final formula for spherical capacitors. So if you have spherical capacitors, the formula is 4 pi epsilon naught R1 R2 minus R1. Now we'll do a question, a derivation only in the form of a question. So I'm writing down the question. You also note down the question. Then we'll do, it's a kind of derivation only. So see, these are the two parallel plates capacitors. So let's say this one is positively charged. We are doing it in the form of a question only, but it's one of your derivations. Because you can get directly numerical values and you have to put in. So we are calculating the force between the plates of capacitors. So this is minus Q. Now see, electric field, if I say what is the electric field due to this positive plate, let's say the separation between both the plates is small d. So electric field due to this positive plate, definitely it will move away, direction will be in this manner. E will be the direction of electric field. Now if I write the electric field due to the positive plate. So if I tell you sigma is the surface charge density, what will be the electric field due to this plate?
Sigma by epsilon naught.
Sigma by epsilon naught for single plate. For single plate, it is 2 epsilon naught. When we had considered for both the plates, then only we took sigma by 2 epsilon naught, because sigma by 2 epsilon naught plus sigma by 2 epsilon naught gave us sigma by epsilon naught. So because of the positive plate, it will be sigma by 2 epsilon naught only. So sigma you can write as charge by area. So if you put electric field will be what? Charge by area, this is 2 times epsilon naught. Can any one of you tell me what is the relationship between force, charge, and electric field? Yes, what is the relation between force, charge, and electric field? Can you use
E is equal to F by Q.
E is equal to F by Q. If E is equal to F by Q, then definitely F is equal to QE. Now, since we are calculating the force on minus Q, because we have considered this is the case that we have taken. So force on minus Q, that's why I'm putting a minus sign. Now I have the value of electric field. Electric field, just put in this. Force will be what? Minus Q, and then the value of electric field. This is 2 epsilon naught A. this whole thing. So your final answer is what? Minus q square by 2 epsilon naught. This is your final answer. So see, we had done it in the form of a question, but you can get directly charge and area and you can be asked to calculate the force. So if you are given such a case, then it directly means that you have to use this formula. So you can use it as a formula also. So quickly note down this and we'll do one more derivation in the form of question.
Ma'am, can you explain again why minus q came?
Minus q came, see, we have considered what? Electric field on minus q due to, no, sorry, not electric field, force on minus q charge. See, this is positive q, this is negative q. Now I am calculating the force on negative q. This is the force on minus q charge due to the electric field. So if this is the charge, can you tell me if minus q is the charge, electric field is generated due to plus q. So I'll be considering electric field of plus q only. And the force is on minus q. So that's why we have considered it as minus q. Now we have just put in the value of E from here because this is the electric field that has been generated. Clear?
Yes, ma'am.
All right. All right, so we have to calculate the energy density between the plates of capacitor. So again, telling you this question can come in the form of derivation also in your exam, and it can come in the form of numerical also. So you have to find out energy density. See, energy density means what? You will be facing this density term a lot of time. We'll be having current density when we'll be studying current electricity. So see, energy density, this is basically energy per unit volume. You have different terms on different meanings of densities. In case of energy densities between the parallel plates of capacitors, you have energy density, which basically means energy per unit volume. So energy is represented through this capital U sign, volume is represented through this capital V, energy density is represented through this small u, this sign. This is the symbol of energy density. Now, if I say these are the two parallel plates of capacitor, separated by a distance d, area is a carrying the charge q. This is the condition. Now I have to find out area, I have to find out energy, I have to find out volume. If I'm able to find out the energy and volume, I take the ratio and I'll get the energy density. So energy for parallel plate capacitor. Yes, Hanifa, you please tell us what is the energy between parallel plates capacitors in terms of charge and capacitance. In terms of charge and capacitance.
Ma'am, could you repeat?
Energy we had done, no? Energy. We had seen three formula in terms of charge and capacitance, in terms of capacitance and potential. So if in terms of charge and capacitance, can you just recall what was the formula of energy? Look into your notes, and if you are forgetting, turn your pages back. You must have written it in the previous class. Formula of energy.
U is equal to epsilon CD.
U is equal to
Epsilon A.
epsilon naught energy. You must have done. U is equal to. Okay, Kulsum.
U is equal to Q square by 2C.
Q square by 2C. Perfect. See, Hanifa, we had done these three formulas. For all those who are forgetting this, these are the three formulas. All right. So, whatever you are given, on the basis of your data, use whichever is the desired equation. All three are same only. It's just that we have converted one form to another. So half q square by 2c, half cv square. Half cv square is the most common one. Then qv by 2, whichever you are convenient with, just use that. So these are the formula of energy. So yes, as rightly answered by Kulsum, we have the energy as what? Q square by 2c. This is the energy. Regarding volume, if area is given and I have this thickness, see, area is calculated, volume is calculated how? If you know the area and if you multiply it with the thickness, then you get the volume. So volume will be area, and the thickness means what? Separation between the plates, that is D. So this is the energy, this is the volume. Now I just have to take the ratio to find out energy density. This is Q square by 2C instead of energy, and in place of volume I have written AD. Now one more thing, capacitance. Yes, this we have discussed. Hiba, that time you didn't tell us. Now tell us, what is the capacitance between two parallel plate capacitors? See, nothing is mentioned. It means air is completely filling it. Yes, Hiba. Quickly answer. What is the capacitance between two parallel plate capacitors?
Epsilon naught A by D.
Correct. It is epsilon naught A by D. So C is what? C is epsilon naught A by D. If nothing is mentioned to you, no, then this is the general case. If anything is different, then it will mention you. So I just have to put the value of it. So U means this energy density will be what? This is Q square by 2 AD, and instead of C, I'll be writing epsilon naught A by D. So this separation dd will get cancelled and I'll be left with q square by 2 epsilon naught a square. If you are able to recall, q by a is what? Yes, charge per unit area is what?
Sigma.
Sigma. Surface charge density. This is charge per unit area. So sigma square will be what? Q square by a square. It means this q square by a square can be written as sigma square. So U will be what? This will be half. I have sigma square divided by epsilon naught. This much term. Now, this formula you can use, but many a times we have to relate it with electric field. So we'll not stop here. What we can do, if I multiply the numerator and denominator by the same thing, there won't be any effect because this just gets cancelled and you get the answer as 1. So there is no effect if you, even if you multiply and divide the denominator by epsilon naught, because this is the same quantity. Now, if I write this as half sigma square by epsilon naught square, and I'm leaving this sigma epsilon naught aside. Sigma by epsilon naught, this is the total energy between, total electric field between both the plates, if you remember. Sigma by 2 epsilon naught is for one plate. For two plates, you have sigma by 2 epsilon naught. So this is the electric field that you have. So squaring this electric field, if I square it, I'll get this only. It means energy density is what? This is half electric field square epsilon naught. This is your complete final answer. And please remember, this is very important. This has come a lot of time in your entrances, your NEET, JEE, and all your entrances. This has come a lot of times. Energy density. Many a times the direct formula has been asked. Many a times electric field has been given and you are asked to calculate it. Sometimes only energy is asked. So you can multiply it with volume because energy density is energy per unit volume. So if energy is asked, you can multiply this by volume, you can get it. And one more important result that is derived from this only, which comes in your examination, that says that your energy density, energy between the plates of capacitors, directly depends on what? It directly depends on the electric field. So this shows that energy between plates of capacitor depend on electric field. Energy between the plate depends on electric field. All right, or the energy stored in the capacitors. Is this clear to all of you?
Yes, ma'am.
Fine. So just note down this as well. See now, sharing of capacitors. Instead of capacitors, you can apply the same logic for conductors also. Sharing means what? Sharing means grouping. Like if I have one conductor with me, I have another conductor with me. So listen this carefully, because the sharing of conductors, the same is valid for sharing of capacitors. So you have one conductor with you, you have other conductor with you. Now both of them will be having their certain potential. Let's say the potential of this is, let's say this is 4 volt. Let's say the potential of this second conductor, this is the first, this is the second one. Let's say the potential of the second conductor, this is 2 volt. Now see, potential will flow, I mean the current, when if you connect both of them, if both of them are connected together, then charge will flow. Charge will flow from where to where? Charge will flow from the one having higher potential to the one having lower potential. The one having higher potential to the one having lower potential. This is the flow of the charges. This is the direction of flow of charges. Now, how much they should move, or till when the charges will keep on moving? Till the time both of them achieve the same potential, equal potential is there in both of them, then only this flow of charges will stop. So for example, if this is 4 volt, this is 2 volt, until this will become what? 3 volt. This will become what? 3 volt. Both have achieved the same voltage. That shows that both of them have the same voltage, and now no charge flows. So charge flows as soon as you connect the capacitors or you connect the conductors from the one having the higher potential to the one having lower potential, until the time they'll move until both of them achieve the same potential. This is valid for capacitors, this is valid for conductors. Now in case of capacitors, if I say, let's take 2 capacitors. This is first capacitor that I have taken, this is another capacitor. This is the positively charged plate, this is the negatively charged plate. This is C1, and let's say the potential is V1. This is C2 and the potential is C2. So what will be the charge on it, Akifa? What will be the charge on this capacitor?
C into V.
E into V, C1. C1 into V1.
V1.
So the charge on this one will be C1 into V1. And similarly, the charge on this will be C2 into V2. So these are the charges before sharing. Now we have not connected them. This is before sharing. Now somehow by means of wire, if I connect both the capacitors, this was the first capacitor, now I have connected it with the second capacitor. So there won't be any effect on the capacitor. This will be C1, this will be C2. But now the charges will flow from the one having higher potential to the one having lower potential till both of them achieve the same potential. So this is the case after sharing. This is the case after sharing. So on connecting 2 capacitors, now if you connect, on connecting 2 capacitors, if you are connecting 2 capacitors, then charge flows. If you connect 2 capacitors, then charge flows from, Atif, you tell us, from which one? Higher potential to lower or lower to higher?
Higher to lower.
Higher to lower. Flows from the one at higher potential to the one at lower potential. This is the direction. Until when, Fatima?
Until it becomes equal.
What becomes equal? Potential becomes equal until both of them acquire the same potential. Until they acquire the same potential. So this is the principle of sharing of capacitors if two capacitors are shared. Now, if I want to know what is this voltage that is coming after sharing, what can I do? See, whatever extra charge is there in one of the conductors, this is flowing to the one that is having the lesser charge. We are not adding any charge, and neither we are adding any charge nor we are deleting any charge. It means the total charge will still be the same. Whatever is the additional charge in one conductor, that flows into the other conductor, which is at the lower voltage. But if you consider the charges, the net charge of the system will still be the same, because only charge transfer has occurred. There is no gain or loss of charge from within the system. So it means charge, all the charges before sharing, this is still equal to the charge after sharing, because the net charge in the system is still the same. This is equal to the charges after sharing. So before sharing, this was the case before sharing. Q1 was C1V1, Q2 was C2V2. So total charge before sharing becomes what? C1 plus C1V1 plus C2V2, means the sum of Q1 and Q2. This is the total charge before sharing. So total charge before sharing, this is C1V1 plus C2V2. This is the total charge before sharing. Now, after sharing, yes, Hamza, you tell us what will be this charge now. C1 is the capacitance, V is the potential now. Yes, Hamza. C1 is the capacitance, V is the potential. What will be the charge? Hamza, you only told me. No, that was someone. We have discussed, Hamza, what is the relation between charge, potential, capacitance. See, you can take the help of this. If capacitance was C2, potential was V2, so charge was C2V2. So if capacitance is C1, potential is V. Hamza, what will be the charge?
C1V.
C1V. See, Hamza, capacitance is charge by volume, charge by potential, Q by capital V. Charge by potential is capacitance. So charge will be what? Capacitance multiplied by potential. So Q1 prime, this will be C1V. Hamza, you only tell us what will be the charge for this capacitor.
C2V.
C2V. See, Hamza, what did we do? We had this capacitor C1V1, we had capacitor with C2V2. V2 is the potential. The charges were these, and this was the case before sharing. Now we have connected them, and we have seen whenever you connect two capacitors, they'll have a common potential V, which we have assumed. So we are trying to calculate that common potential. So charges before sharing are these, and the net charge after sharing is C1V plus C2V. Now I have to just take out potential as common. This is C1 plus C2. V will be what? This is C1 V1 plus C2 V2 divided by C1 plus C2. This is your common potential. Common potential achieved when both the capacitors are connected by means of wire or anything. This is the common potential. Clear? So there's a loss of energy also associated with this, but I think first you note this down, then we'll calculate the loss in the energy. Written till here, common potential.
Yes, ma'am.
Yes, teacher.
Alright, so let's discuss what is the loss of energy in this process. Now, loss of energy is very simple to calculate. It's just that this will look lengthy to you, but it is very, very easy. See, loss in energy is calculated how? Whenever you have to find the change in energy, how do you calculate it? You take final minus initial. You are calculating the loss, means loss can come in negative because that negative sign will only signify that loss. It means you have to take the initial energy, whatever is the initial energy, and then subtract it from the final energy. This will be your total loss in energy. Initial energy minus the final energy. So we'll use the formula half CV square. Half CV square, with the help of the formula, we'll use it. Now regarding initial energy. This was the case. C1 is the capacitance, V1 is the potential. We are using the formula half CV square. So this will be half C1 V1 square. So the energy for this capacitor, this is what? Half C1 V1 square. Similarly, the energy for this capacitor U2, this is half C2 V2 square. The common potential, after achieving the common potential, the potential C1 is the capacitance, V is the potential to this. So this will be half C1 V square and U2 will be half C2 V square. Clear how to write all these energy? Is it clear?
Yes, ma'am.
All right. Now see, initial energy is what? Initial energy is basically the sum of these two energies, no? The sum of energies of the two capacitors before sharing. This is only your case before sharing. So before sharing, will be the total energy. Now after you have connected both of them with the help of wire or any means, this after sharing that you are getting both of the sum of these two energies, this will be the case of after sharing. So just take out the difference, you get the loss in energy. So this is also one of the derivations that come in your exam. So, but it is very easy to calculate, just do by this method. Take the energy on one capacitor, take the energy on the second one, add them. That is the case before sharing. Take the common potential and take the energies of both of them and then sum it and you get it. So initial energy will be what? Half C1 V1 square plus half C2 V2 square. This is the total initial energy minus half C1 V square plus half C2 V square. This is the final energy. Now you just have to put in the value of the common potential that you have calculated just before. Once you get the value of the common potential that you have just what you have written, V, that common potential, you just have to do your basic mathematics. Cancellation is there. It will look lengthy, but it is very easy. See how we'll do it. From here, first let us just take half capital V square common. This will be half C1 V1 square plus half C2 V2 square. And let's take half V square common. So we are left with C1 plus C2. Why? Because we can, so that we can easily put the value of common potential. Common potential is what? Common potential is C1 V1 plus C2 V2 divided by C1 plus C2. Remember, you can get questions directly on common potential as well. Otherwise, it is used in this manner. Now we just have to put the value, this whole value in term of V. So V is this, V square will be the square of this. So delta U will be what? This is half C1 V1 square plus half C2 V2 square minus half. We are just putting the whole value. Let's say this is C1 plus C2. Now V square means I am putting C1 V1 plus C2 V2 whole square divided by C1 plus C2 whole square. What did I do? I just squared the value of common potential so as to receive V square. Now see, C1 plus C2 is getting cancelled by this. Apart from this cancellation, half is common in every term, but C1 plus C2 is coming in the denominator. So whenever you have to solve any equation further, how do you solve it if denominator is different? If denominators are different, you take the LCM of them. So we'll also take the LCM in this case. So delta U, this will be what? Just take the LCM, will be C1 plus C2. This is half C1 V1 square. Multiply it with C1 plus C2 plus half C2 V2 square. Multiply this term by this is square. This is C1 V2 square and this is C1 plus C2. This will be the same. There is no difference over here. This is C1 V1 plus C2 V2 whole square of it. So since we have taken it common, we can write it in this manner, no? Since we have already taken it common, we can write that 2 in the denominator and C1 plus C2. This is how you take LCM. First tell me, is this step clear? Because if this is clear, then we just have to open up the brackets. Anyone is having any doubt, any difficulty in any of the steps? Clear to all of you?
Yes, ma'am, clear.
What about others? Only Krishna has responded.
It's clear, ma'am.
Clear? All right. So now, if this is clear, now this is your basic mathematics. We'll just open the bracket so that our calculation becomes easier. This will be C1 square V1 square plus multiplied with this. This is C1 C2 V1 square. Open up the bracket. This is plus C2 V2 square multiplied by C1 plus C2 square V2 square. We have opened up this bracket. How are we opening the brackets? Just multiplying this term first with this, then with this. We have got this. Then multiplying this term with this, multiplying this term with this. Then minus C1 V1. Okay, this identity we can open. C1 square V1 square. This will be, since this is minus, this will be minus C2 V2 square minus 2C1 C2 V1 V2. This will be the whole thing that is there. Now see, C1 V1 square, some things will get cancelled, and in the denominator you have 2 C1 plus C2. So is anything getting cancelled? Yes, the C1, this is getting cancelled, this is getting cancelled. Now nothing else is getting cancelled. Now C1, C2, if I take common, C1, C2 from all the three. If I take C1, C2 common, I'll be left with V1 square from here plus V2 square from here minus 2V1, V2 from here divided by 2C1 plus C2. Yes, are you able to see any identity in this?
Yes, ma'am.
Which one, Krishna?
V1 minus V2 the whole square.
V1 minus V2 whole square. The identity that you have, algebraic identity, this will be V1 minus V2 whole square. That's how you write the identities. Divided by 2. This is C1 plus C2. This is your complete loss in the energy. This is your loss in energy. Okay, so just to clear this, make it more clear and to clarify all your doubts, we'll do a question also based on this. So firstly, you note down this derivation and try to solve it on your own. You know how to solve it. Initial energy minus final energy. And then put the value of common potential and see the resultant. Again, reminding, you can get the questions directly on this common potential as well.
Can you scroll up? Okay.
See, it says, the question says a capacitor of 10 picofarad. This is charged up to the potential 20 volt. So capacitance is what? C1, capacitance is 10 picofarad. Potential V1, this is 20 volt. Then it says this is connected to identical capacitors. Capacitor means the capacitance is same. Capacitance is same means C2 is also 10 picofarad. V2, it says it is uncharged. Though it is identical, but it is uncharged. So if it is uncharged, this means that the potential will be zero because there is no charge. So V2 is zero. You have to find out the common potential. We have done the formula of common potential. V is equal to C1 V1 plus C2 V2 divided by C1 plus C2. Then loss of energy is this. The formula is there on your screen. So quickly, everybody, send me both the answers. All the data is in front of you. Both the formula are there. You just have to solve it. But do convert capacitance into SI unit. Pico, 1 picometer. If you remember, can anyone tell me, by the way, how do we convert pico?
10 to the power minus 12.
Minus 12. Correct. 10 to the power minus 12. So this C1, which is equal to C2, this is equal to 10 into 10 to the power minus 12 farad. Pico is always converted in this manner. Quickly send me the answers. Common potential is also, the calculation is very easy. Just try it yourself. Take 2 to 3 minutes. Send your answers, all of you. All of you should try this question. So first part's answer, correct answer, Akifa has given, Kulsum Khan has given, Atif Ahmed has given. First part correct answer. Regarding the second part, Atif, second part is not correct. Please check once again. Your first part is right. Just put everything in the formula in loss of energy. Fatima, your answer is 2 into 10 to the power minus 12. There is some error, Fatima. Just check once again. Others also, please try. Only Fatima, Atif, Kulsum and Akifa have tried this question. Fatima, Munir, you answer. Hamza, Hanifa, Hiba, Huzefa, Krishna. Yes, Kulsum, your second answer is also correct. So Kulsum has answered both the parts correctly. Others also, please try. Krishna, you also answer. Huzefa. Yes, Krishna, both the parts are correct. Hamza, try the second part as well. Last 2 minutes, then we'll discuss. Quickly, rest of you also please try. Hiba, Hanifa. See, the terms are given in front of you. 10 to the power minus 11 becomes your capacitance. V1, you know it is 20. V2 is already 0, so this term will be 0. C1 plus C2 calculate. Once you get, at least give the answer of the first part. Calculations are very easy. Yes, Atif. Now your both the parts are correct. So Krishna, Atif and Kulsum. Both of all three of them have given the correct answers of both the parts. Hiba, some error. Hiba, this is the answer of which part? First part or second part? The answer that you have submitted. Akifa, correct. Perfect. Both the answers are correct now. Okay, Hiba, so this is the answer of the first part. Let's discuss it now. I think this was enough time to solve this question. Regarding the capacitance. Capacitance is what? Both the capacitance are equal because it is mentioned that both of them are identical. So this is 10 to the power minus 11 farad. The rest of the things are given. V will be what? C1 is 10 to the power minus 11 multiplied by V1 is 20 plus C2 is 10 to the power minus 11. V2 is 0 because it is uncharged. So we have taken second potential as 0 multiplied by 0 divided by 10 to the power minus 11 plus 10 to the power minus 11. See, this term becomes 0. And V is what? V is 10 to the power minus 11 into 20 because this term is 0, so no need to write this term. Divided by, you are adding the same number 2 times. So you can just simply multiply the number by 2. This is 2 into 10 to the power minus 11. If you write 10 to the power minus 11 plus 10 to the power minus 11, or you write it as 2 into 10 to the power minus 10, you'll get the same answer. So by this, what will happen? Your cancellation becomes easier. Now 20 divided by, this will be 20 divided by 2 and your common potential will come out to be 10 volts. So 10 volts is the correct answer. So all those who have committed error, just see where was the mistake done. Now loss in energy, similarly, you know the formula for loss in energy. You have to calculate it using that. So for the second part, loss of energy is what? This is C1, C2. V1 minus V2 whole square divided by 2C1 plus C2. This is it. Now C1 is what? 10 to the power minus 11. C2 is what? 10 to the power minus 11. V1 is given 20. V2 is given 0 whole square. Just put in the values in the formula. Formula based question. This was formula based question. Now 2 multiplied by again 10 to the power minus 11 plus 10 to the power minus 11. So this will be 10 to the power minus 22. This is 400 square of 20 divided by. This is 2 multiplied by. Again 10 to the power minus 11 plus 10 to the power minus 11 can be written as 2 into 10 to the power minus 11. So this becomes what? This becomes 2 into 200. This becomes 2 into 100. So this is 10 to the power minus 11 multiplied by 10 to the power 2. This is 10 to the power minus 9. So the loss in energy is what? 10 to the power minus 9 joules. Now tell me, others, is it clear? Hiba?
Teacher, what is the conversion from picofarad to
Picofarad to farad. Whenever you get pico, no, even if it is 1 picometer, if it's 1 picocoulomb, if it is 1 picofarad, this pico term, replace this p term with 10 to the power minus 12. The way you convert micro, how do you convert micro? You multiply by 10 to the power minus 6. How do you convert milli? By multiplying it by 10 to the power minus 6. Nano, nanometer, nanocoulomb, nanofarad. Nano is written 10 to the power minus 9. Pico, 10 to the power minus 12. Fatima, is it clear?
Yes, teacher.
So all those who did not write it, now just write the solution. And all those who will keep on writing this and all those who have written it also, just text me done. I want to know all those who have completed it and all those who are writing it. Just write me done apart from Krishna, Atif, Kulsum and Fatima. Fatima, Munir, how did your test go?
It was really good. The questions were really general and nice.
All right, good. It's fine. Okay, Hanifa, Hamza have also written it. Oh, as you keep on writing, please type done. Josefa, Hiba, done.
Ma'am, you're talking about the online test.
No. She had her school exam. Online test, you will be having a test right now. Are you aware of? The syllabus must have been shared with you all, no?
Yes, ma'am.
The subjective test right now only. That's why I'm asking you who all have done. So if everybody is in, can we start with the test? It's just half an hour, 5 questions I've given. Easy questions. Can we start?
Okay, ma'am.
All right. So let's begin with the test. See what you have to do. I'll be sharing the question paper with you. Now, what you do is that there would be some group on WhatsApp where you would be getting your meeting IDs daily. Yes or no? So if
Yes, ma'am.
you have a group, no, where you will be getting meeting IDs daily. So start the test right now. I am giving you half an hour time is sufficient for 5 questions, subjective questions. Then submit and upload the PDFs. All of you, just begin.
Teacher, can you increase the size?